Well, hello everybody. Welcome to today's session. We're going to be continuing our discussion about secure application development for IBM I. And it is my pleasure to be back with you to speak to you on this topic. My name is Robin Tatam. I'm the Director of Security Technologies here at Help Systems, and my role kind of entails teaching and in sharing knowledge about security on the I platform. And as a developer by trade, this is one of my favorite topics to talk about because I certainly recognize that early on in my career, when I was building applications for organizations, I honestly have to admit that security wasn't really front and center. Granted, those were back in the days when we had TwinX and dumb terminals, so we didn't have a lot of exposure from outside organizations trying to get into our systems, but certainly recognize that as that kind of connectivity has evolved, we still kind of approach application development with the same mindset there, whereby we're trying to build these applications and deploy them to the hands of the users to solve the business challenge. We don't necessarily put security up as part of that initial development. So hopefully, as part of our discussion here previously and also in this session, we're going to help you understand why that is important. Now, I know how much fun we're having here. This is part 2 of 2. So if you're coming in here and you have not listened to any of part 1, this may build on that, but certainly would recommend that you access those recordings or the recording from part 1 and listen to that. If you're just coming in here as a follow-on, then everything should build on what we learned previously. So where we left it was the idea that when we are over-securing an application object, we may see this kind of CPF 2207 message. As a reminder, we want to make sure that we're auditing our system, looking for any type of important events. And so assuming that that auditing has indeed been activated, then you would expect to receive an AF or authority failure entry into the audit journal, indicating the name and location of the object which the user is unable to access. Now, the benefit of having the auditing turned on, of course, is for troubleshooting. But ultimately, what we don't want to do in response to something like that is provide all object to the user who was experiencing the challenge. Certainly, that will fix the problem. They will now be able to access that object, but they can also access everything else, including the other user's profiles and even the operating system. Granted, if it's 3 o'clock in the morning on a Sunday and you're trying to run a payroll application and it's critical that that application be run, this is a short-term solution, but this is not the end goal here. This is like trying to put in a finishing nail with a sledgehammer. It is complete overkill. And in fact, what we're doing in many instances is trying to reduce the number of users with all object. So the answer when we experience an authority failure is not just to simply grant all object, because like I said, it tends to be significant overkill. And we talked about public authority before, but what I want to talk to you about now is a concept called private authority. Now, private authority is really kind of named permission. It's based on the user themselves or a group profile perhaps that they belong to, in comparison to the public authority, which, as a reminder, is kind of what I refer to as anonymous access. I don't mean anonymous in terms of somebody from outside the organization who just happens to have a connection to the internet. What I'm talking about by anonymous is we acknowledge that the user has credentials to the system, but we don't necessarily know why they're on the system. Usually we have multiple applications, and we haven't identified this user perhaps yet as to why they're there. Now, this contrasts the private authority, where we have very explicitly and deliberately named a profile or group so that they have access to objects. Private authority can, in theory, be more restrictive than the public permissions, but typically it's going to be less restrictive. And we use terms like deny by default and least privilege, which I've put on the slide here, in order to describe that, whereby if you simply have shown up, you've signed onto the system with your valid credentials, then what we expect is that you still should have no access to the database. Once the user has identified as being a legitimate application user, then perhaps we crack the door a little bit for them. If they're a privileged account, then maybe we open the door a little bit more. But in essence, we keep starting off with a closed door and gradually opening it up. When we look at permissions on objects using the display object authority command, what we'll see here is a list of profiles that are shown against that object, and these are the private authorities. Now you'll see at the top of the list there's star public there. That is the definition that we talked about previously with regards to how much authority the all-encompassing user has, but here we've explicitly provided permissions to two profiles, one called payown, one called read-only. Now, in this case, payown is actually the owner of the application. You see that up in the top right-hand corner, or the owner of this particular object at least, and therefore it's been given all permission to the object as its default. Here we see an additional user that has been granted read rights to this file by the name of a profile of read-only, and this is considered a private authority because it's for a specific user, or based on the name of this user, perhaps it's a group profile that's in effect. All right, so let's explore the group profile concept a little bit at this point. So we hear terms like role-based access control as a common buzz term in the industry, but really we've been doing role-based access for as many years as the AS400 has been around. In fact, we have just a slightly different name for it, and that's group profile. The concept being whereby we list off the attributes and the permissions that are appropriate to a group of users, and we only have to do it once. So even if I have perhaps 15 order entry people, I can assign them to one single group, give the privileges necessary to the group, and it makes my life easier from an administrative perspective. Okay, so that's really all a group profile is. It's consolidating or linking users together that have a common security requirement so that we only have to deal with one entity instead of many. It's possible for a user to belong to up to 16 groups. This is handled through parameters on the user's own profile. One's called the primary group, or actually just group profile, and there are 15 supplemental groups available on a second parameter called supplemental groups. I've put a note up here, don't go group crazy, and what I mean by that is if a user belongs to more than, say, 5 or 6 groups, you've probably gotten a little bit too granular, and you may want to consider paring that down. Okay? Now, when a user belongs to a group, they're going to inherit any private and special authorities from all of their groups. So if a group profile has all object, so do all the members, and that's something that often catches people out when they're auditing their profiles. They don't recognize that inheritance is actually happening. If a user belongs to multiple group profiles, then they actually can consolidated version of all of their groups, which is very helpful and does tend to lead to confusion sometimes if, for example, one group has all permission and the other is excluded. The group profiles are simply there for organizational reasons, as well as that authority inheritance. And we really don't expect nor desire somebody to sign on as the group. This is kind of like why we don't want people to sign on as the object owner. Reason being, I lose accountability, especially if there's possibility that multiple users could be signing on to this user profile, because then if something happens, I don't really know who the human being was that did it. Okay, so we create a group profile much like any other. We use the create user profile command, or we can use Navigator to create that. The parameters that I tend to recommend are things like password none, initial program none, initial menu sign off, and limit capability yes. All 4 of these are geared towards preventing the user from being used as a traditional profile. And you may recognize that this looks awfully similar to the profile that we created earlier that was designed to simply own application objects. The group profile itself is just like any other user profile. You create it the same way, and really the designation of it as a group comes from the fact that we assign it to an individual. So in this case, you can see that there is a profile in the background here, and there's a group profile that's specified that's indicating that the sec admin's profile should be the group. Okay, and if that sec admin's profile wasn't already a group, it will be now. Granted, there are other ways to, in essence, indicate that a profile is a group, but this is by far the most common. It's simply the indication on another user's account that the group is indeed a group. Now, there's another concept we want to be aware of in security. It's another organizational mechanism that makes our life a little bit easier, and that's called an authorization list. Now, this is designed to kind of consolidate or group together similar objects, okay, and similar from the perspective of what their security requirements are, their permissions. Now, any object that is secured by an authorization list is going to get its private permissions and potentially its public permissions from this authorization list. In fact, the list is not giving any more or any less authority. All it's doing simply is centralizing the definition of the permissions to one place. So if you have 100 objects and you want to link them onto one list, you now only have to deal with one set of permissions, not 100. You can still specify exceptions to those rules by specifying permissions privately to the object individually. And these permissions will override anything that is designated on the authorization list. So if I'm one of the 100 order entry people, and there's some exceptions whereby I should maybe have more or less permission than the other 99 order entry people, then I can still specify those exceptions at the individual object level. You create an authorization list with the create authorization list command. You'll see that in step number 1 here. The authorization list is provided, and we also have designated the public permissions on that authorization list. Notice that there is no library name designated along with the authorization list, and that's simply because under IBM I, every authorization list lives in the QSYS library. Step 2 then entails adding or maintaining the list entries, which we do in a similar fashion to the library list using the add authorization list entry or edit authorization list. This is again where we designate all of our permission settings centrally for any object that is linked to that list. The concept of an authorization list sometimes is lost on people because they say I don't have that many objects and maybe I'll just maintain them manually. My kind of stance on this is that authorization lists are extremely beneficial from an organization perspective, but they're also extremely beneficial if you run a 24/7 shop. Why is that? Well, partly because when you want to change the permissions on an object, you as the administrator have to gain a lock on that object, which in a 24/7 shop may be not possible. So with an authorization list, what you're able to do is gain a lock on that object one time in order to assign the authorization list to the object. And then on an ongoing basis, when you're changing permissions, you're actually changing them to the list, not to the secured object. So you can do that even when a file or a program is in use. So even on a small application, with the possibility that perhaps it may need changes or it may grow into a big application, I'm a big fan of setting up authorization lists right from the get-go. You don't have to use them. This is an optional thing. It just makes your life easier. Like I said, I'm a big fan. I've used them from a long time ago and continue to use them today. I've got down here in the second paragraph that it may help future-proof your application. The reason being that there may be changes that come along down the road that weren't anticipated during the original application design. And if we do have to open the door perhaps to an ODBC connection coming in, and we want to potentially add the permissions of an ODBC user, then I can do that to the authorization list without having to gain that lock and interrupt the flow of the application. So what do these look like? Well, this particular object here is called pay new. This object is not currently secured by an authorization list. You see up there it says star none. And that means any of the permissions over on the left-hand lower side in that list there are what are going to control who has access to the object and how much access. When we assign an authorization list, you'll see its name appear as part of the object authorities. Now what we see on the left-hand side are, in essence, the exceptions to the rule of the authorization list. So in this case, regardless of what's on the authorization list, read-only is getting star used because we take advantage of the list before we defer any decision-making back to the authorization list. That's the exceptions that I talked about a little bit earlier. All right, so we've got this capability of setting exceptions, and this is going to take precedence over anything that might be defined in the authorization list. Now you'll see here that public is set to exclude, okay? And we designated, when we created the authorization list, a public setting on the list. But it's important to understand that the public permissions on an object will only defer back to the authorization list if we designate a special value here of *AUTL. In other words, what's happening when the operating system gets a request from a user is it kind of pinballs back and forth between the object and the authorization list. Meaning that, let's say I'm Robin, and I've connected to the system and I try to access this payroll file. The operating system is going to fall into the flowchart that we talked about last session. And it's going to try to determine if there's anything explicit to Robin in this list. And obviously we can see there isn't. So then it's going to determine if Robin exists on the payroll authorization list. And let's pretend that Robin is not listed there anywhere. It's going to then return back to the list on this screen, meaning specific to this object. And it's going to look to see if any definitions exist for any group profiles that I belong to. Let's assume they are not found in this list, in which case it'll go back to the authorization list again, looking for any references to my group there. Assuming that there's nothing found, it'll make a return back to the object, and it will then pull the public permissions. In this case, it would be *exclude, but let's assume we put *authorization list in here. It would make one last journey back to the authorization list and reference the public authority there. Generally, I recommend that you use this *authorization list on the public setting here because it tends to be confusing to people when they see that there is a public permission on the authorization list and they don't realize that in essence there's this individual authority that is taking precedence on each individual object. So if you truly want to make this as generic as you possibly can, unless there are exceptions on an object level, set the public permissions to be authorization list and then use the public permission setting on that authorization list to determine what the user can do. Now, if that's all a little bit confusing, don't worry. This is all something that can be kind of explained, but I want you just to understand conceptually that there is this ricochet back and forth between the object permissions on the individual object and then the permissions that are designated on the authorization list. Okay. One of the most common questions I tend to get when we have longer sessions is whether I should use a group or an authorization list. What is the kind of distinction between which one I should use? And really my answer is it's not a decision that you have to make. There's no reason why you can't use both of them together. Bearing in mind that group profiles are designed to associate similar users. Authorization lists are designed to help secure objects that have similar security requirements. So their concept is overall similar, but they're targeted at different types of objects. So here we tend to see a traditional kind of permission schema. We've got, say, 100 users and 100 objects. We have to go through for each individual user against each individual object and grant the appropriate permissions. Now, I don't know about you, but having to define 10,000 different permissions is not something I would consider probably a fun job. Now, if we take the after scenario here where we've associated all of those 100 users onto a single group, and we've associated all 100 objects into a single authorization list, there is potential that we only have to use one add authorization list entry command, and we've accomplished what those 10,000 permissions would have accomplished in the before scenario. Now, it's possible that you would have more than one group, and it's possible you would have more than one authorization list, but it's still going to be significantly less effort than the before scenario. So again, consolidating similar types of users and similar types of objects into these mechanisms and then granting permissions in a consolidated way is a hugely beneficial way to go. Last session I talked, or at least mentioned adoption a few times, and I want to talk about that now because it's an important concept to keep in your programmer tool belt. When a program runs, it tends to run with the permissions of the user that ran it, but it is also possible to use adoption, which means that the program can introduce some additional permissions that potentially allow the user to perform a task that they may not normally able to perform. This works by taking the user's permissions and blending in the authority of the application program's owner. Okay, remember, everything is owned by somebody, and now it becomes extremely relevant. Now, adoption only comes into effect if the user themselves, the one that called the application, is unable to do what the program is trying to do. So if the user has the necessary permissions, adoption is ignored. But if the operating system determines the user is unable to do maybe a clear physical file or an end subsystem, then what can happen is the owner of the program that is running can introduce the potential permission there as well. So it's a nice way to augment and allow a user to run a program that performs a restricted task without having to give the user that permission right out of the gate themselves. So here we've got some notes. The program executes with the authority of the user running it in a normal scenario, but we can introduce adoption if the authority check determines that those permissions are not sufficient enough. And then we introduce the authority of the program's owner. We also have the ability to introduce multiple program owners. So if you have nested programs, program A calls program B, we can actually add multiple users into the mix and allows us great flexibility. Okay, so this is a discussion here really in terms of that inheritance from the call stack. Okay, there is a separate setting on each program object. We'll look at each of them here in just a second that controls whether a program should leverage any adoption that was already in effect from prior programs. Okay, now some nuances you need to be aware of with adoption. Number one, the permissions are going to accumulate. You can't take a privileged account and change the user so that they have less permission. Granted, that's something that happens less often, but we do see occasions where a user with all object is going to be put into an interface like query, and we want to try to change their permissions to be lower. And you can't do that with authority. We also have to recognize that adoption is not something that carries through to the IFS, the integrated file system. So if you are doing anything to create or manage stream files as part of your native application, just recognize adoption is not going to be very helpful for you here. Instead, what we would recommend there is a concept called swap profile, which I'll talk more about in just a moment. And then authority can be adopted from multiple owning profiles. What I mean by that, again, is if you have multiple programs in the call stack, each one can introduce the authority of its own owner. Now, in our scenario, when we were talking earlier, we were talking about the idea that there is a single owning profile for the entire application, but that's not a hard requirement. You can have multiple owners. What we just want to shy away from is the idea that the programmer is one of those owners. Okay. The hot tip down at the bottom is very, very important, and it says that if you're going to use adoption and potentially introduce the privileges of a more powerful profile, make sure that you're never putting the user into a screen or application scenario where they may be able to run commands, because there's a very good chance that adopted authority is live and active on that command line. If you adopt QSecOffer, for example, all of a sudden, the user who is on the work spool file screen finds themselves in the enviable position of being able to do basically anything they want. So how do we turn on adoption? Well, there is a parameter on every single application object. In this case, it's a CL program, and it says use a profile. And you can see in this example that it says star owner. Normally, it would say star user, meaning that the permission is only going to be evaluated based on the user who is calling the program. By setting it to star owner, what we've done in essence is activate adoption to say that the owner profile should be used if the user's own permissions are deemed insufficient. In this case, the program is owned by QSecOffer, and if that user's authority is insufficient, then all of a sudden the big guy is introduced into the picture. Again, critical here that we would not allow the user to access a screen that has a command line on it. There's a second parameter, which tends to be a little bit confusing to people because this says use adopted authority, but it doesn't control whether this program uses adopted authority or not. Little confused? I understand. What this really should say is use inherited adopted authority, yes or no, which is telling the operating system whether any permissions that were adopted by programs higher in the call stack than this one should also be leveraged during the authority checks. Okay, so the name of the parameter is a little misleading, but it's related to the inheritance of the adopted authority, not the control for this program. If you would rather not try to remember about the inheritance, then there is actually a built-in function you can control through a couple of procedure calls. I gave the code to you right here. The benefit here is if you've recompiled a program and you forgot to set that use adopted authority program attribute, you can do it programmatically inside the program that is about to call another. So for example, I've got program A that is calling program B. And inside program B, I know it does a work spool file or some other OS command that pulls up a command line. And I'm concerned that the adoption that my application is using is going to be passed through to that command line and abused. So what I can do inside program A is first turn off that inherited value, call program B, and then when I come back, turn it back on again. Okay, so I can do it programmatically versus using the use adopted authority parameter on the object itself. Here I've kind of painted a picture. 3 programs that have been called, A, B, and C. Each one of them has settings that are related to user profile or use adopted authority. First program is owned by app owner. Its user profile option is star owner, which is not the default of star user. So in this case, when the authority algorithm is checked, it will first evaluate the authority of the individual or calling user. If that is deemed insufficient for some reason, then a second check is performed and the privileges of the app owner profile are introduced. And that's because of the star owner designation. When program A calls program B, then what we're going to actually be checking now is the calling user. And if that's deemed insufficient, then we're going to use app owner from program A. The reason being, the use adopted authority flag is set to yes. So remember, that relates to the inheritance portion. If that's deemed insufficient, then we're going to use QSEC offer because user profile says star owner, and for program B, the owner is QSEC offer. There's then a third program called, in which case only the calling user's permissions are used for 2 reasons. Number 1, user profile says star user, which means the owner of this program isn't taken into effect. And the use adopted authority, which is the inheritance value, is also set to no, meaning it's going to forget about any adoption that was occurring in program A or B. Hopefully that helps paint a little bit of a clearer picture in how you can control these values and control them individually to get a lot of flexibility and control over your application environment and what permissions are included in the authority check. So adoption also has a counterpart. There is what's called a swap profile, which IBM built for their own purposes back in the mid-90s to allow an existing job to change its attributes so that it's deemed as running under a different profile than the one that actually started it. You can use this same capability through some API calls, and there's some added benefits to doing so. Now, there's pros and cons to both ways. In this instance, what we see is that when a user swaps to the identity of a different user, much like Clark Kent becoming Superman, what we're doing is actually relinquishing the privileges or lack thereof of the original profile and becoming, in essence, the target profile. That means we're going to benefit from the special authorities, the private permissions, even command line permission that the target profile has. So it's almost as if you signed off and signed on as this alternate profile, but you do so without ever having to sign off and sign back on or even know the password of that target profile. If you look at your job attributes on any job, you can do this on your own system, you'll note at the top that there is job information, the job name, the user associated with that job, and the job number, which makes it unique. If you look at the job run attributes, you will see that there's also a current user profile and a job user identity. And typically, all 3 of those user parameters are going to reflect the same user. In my instance, however, I've used the swap APIs to actually tell the operating system in this case that I'm QSEC offer. And anything I do on the server, the operating system thinks QSEC offer did it. So if I do a work spool file, it's going to show me QSec offer spool files. If I create an object and tell it that I own the object, it's going to be owned by QSec offer. The beauty, however, is that any auditing that occurs on my job is still going to flag that our Tatam was the instigator. And this is very beneficial if I have multiple users all swapping concurrently into the same profile. Again, I don't have to sign off and sign back on, so I don't have that headache. I don't have to know the password. So if I'm swapping into maybe the group profile to do some maintenance on my application, I can do that. But all of the auditing points back to me as our Tatam, which from an audit perspective is really the end game. So this is a great feature and a great capability. The invocation of performing a swap is handled through several different APIs. I'm not going to get into each of these here just because of the scope of time that we have, but they're not difficult APIs to use. And if you're thinking, well, that seems kind of dangerous, what if John in order entry decides he wants to be QSec offer today? There are rules around how these are invoked and how users access them. This tends to be a bit of a showstopper because we see things like users needing to have use permission to the profile they're swapping to. Well, we certainly don't want to set up public permissions on the QSec offer user profile. So how do I do this without creating a bigger security issue than I'm fixing? Well, I suggest people use adoption. And adoption will allow a shell program that is using these APIs to elevate the privileges of the calling user. We talked about adoption just now, and we saw that we can change the permissions to include the designated owner of an application. So all you have to do is put the shell programs inside, the swap APIs inside a shell program, and then have the shell program run with adopted authority. And you can use that, of course, to satisfy the rules. So we can combine these two things. Again, they're not mutually exclusive. As a programmer, you're probably used to retrieving the name of the current user, and that's something that we tend to do using the second parameter in this list, where it says user. Now, when IBM introduced this capability, they also enhanced this retrieve job attributes command so that you can retrieve the current user. And I would suggest that's probably what you should be retrieving in a normal business scenario. If there is a specific requirement to retrieve who signed on and who started the job as opposed to who is currently running, then sure, retrieve the original user parameter. But for all other purposes, current user is the way to go. If there are no swaps currently in effect, meaning the user has not swapped to a different profile, then it will still retrieve the name of the job user. So it should always work. This is just a more modern way to retrieve it and will allow the user to be differentiated from the user who signed on. Using swap profiles fixes some of the issues we have with adoption. For example, this now is honored within the integrated file system, and because you are relinquishing the privileges of the original user and gaining the attributes of the target profile, it is possible to downgrade permissions so that all object user can now be given permission to query, knowing that we have downgraded their all object to something less powerful. It's also supported in non-5250 interfaces like FTP or ODBC. So in exit programs, you're now able to indicate that even though the user is signed on as Robin, the permissions should be evaluated as if I had signed on as read-only. Right? This is all very flexible because it's turned on and off programmatically, but bear in mind you can only swap to one target profile at a time, where adoption allows us to introduce the permissions of multiple owning profiles. One last thing here, the same tip as we had on adoption. If a user is swapped to a more privileged account, we want to be cognizant that if we present that user with a screen with a command line on it, that we don't want to include the swap through to that screen. So you may have to swap back or just avoid presenting the user with a screen with a command line. All right, so we've introduced ownership, we've introduced public authorities, we've introduced private authorities, group profiles, authorization lists. These concepts now are all going to be brought together in a simple security model. I'm not suggesting this is the only way to build an application. I love different flavors of ice cream, just like I love different flavors of applications. But what I'm going to do is build very quickly a simple native application using adopted authority within a library that prevents direct user access. So I'm going to give you the commands that I would use just so that you can kind of hopefully pull together all of the concepts that we've introduced. First of all, we're going to create the owning profile for our application. So here you see a standard create user profile command. We're going to call it app owner. We're going to give it parameters like password none and initial menu sign off and no command line permission in order to really indicate that this user should not be signed on as, and that if for some reason somebody gives it a password, hopefully there's other layers of security that will catch it and sign the user back off. So this is there simply to own the application. I don't want anybody signing on, and I've configured the profile accordingly. After I create the profile, then I'm going to potentially create a couple of authorization lists. I've chosen 2 here. The reason being, I know that my program objects like RPG, CL, COBOL, whatever it may be, are going to have different security requirements than perhaps my data files. So I have an authorization list here for data permissions, my files, my data areas, things that are changing on an ongoing basis. And then I have a separate authorization list for my programs. Each of them has the default public permission set to exclude. And then what I've done is change the ownership of that authorization list to be owned centrally by my brand new app owner profile. I'm doing that for consistency to make everything owned by the same profile. Next thing I'm going to do is create a couple of libraries. I'm going to separate again the programs from the data. So the first library is for my application objects, my CL, my RPG. The public permission to this library right now is *use, and the create authority, which references the amount of public permission given to any object that I create inside that library to *exclude. I don't want anybody accessing those objects directly. I'm then going to change the object owner to be consistent with my app owner profile as we've done previously. I'm going to repeat that same step with the data library. Difference being now it's public exclude. I don't want anybody accessing this library or its contents directly. I'm going to use authorization lists again, even to secure the libraries. Now, some instances I may have different authorization lists to the library versus the object, or I may not even use authorization lists at all for the library. But in my instance, I've chosen to, and I've simply allocated each library to its associated authorization list. Then I'm going to create my physical files and maybe some data areas, things that are geared towards hosting variable data. Again, I'm using my create command. I'm referencing the public permissions to defer back to the library. Remember, we had that kind of daisy chain back from library to system value, and I suggested cut it off at the library. So here, I'm saying that I want the permissions for this file to come from the inheritance from the library. Just makes my life a little bit easier. Again, owner is established just as it is with every object. And then again, I'm instructing the file to get the permissions from the authorization list. So this is where we have a specific authorization list associated with this file. Very similar with the application programs. I'm going to create those in my program library, again, inheriting the public permission from the library attribute and assigning a consistent owner. You guys starting to see a pattern here? We're creating things in a very similar fashion. We want everything owned by a consistent basic profile, and then we're establishing the permissions to those objects and attaching them in the last command here to the authorization list. So we're repeating this probably for all our files and for all our programs. Now we're telling the public authorities on these objects to also come from the authorization list. Remember, if we don't do this, the operating system has an explicit public permission on everything, and it will take it from there. We have to tell it to make that ricochet one final time back to the authorization list to get its deferral back from there. All right. Now, here's where the magic happens. That's a lot of attributes to be set, but notice we didn't really set any attributes associated with the inheritance or adopted authority that I talked about. But That's where we're going to do it now. So let's assume that there is a program that is called, a single program that starts this application, gets me either to the main menu or to the primary application object. And I'm going to change that program so that it has a designation of user profile star owner. So who is this application owned by? It's app owner, remember? Everything. The files and the programs are all owned by app owner. So by elevating this program allows the user who can call this program to benefit from the authorities associated with the owner. And as a reminder, owner gets star all permission to the objects. Okay, so by introducing app owner as part of the authority check, this application can do anything that it needs. The other thing we have to remember is that inheritance factor is something that by default says, yes, I do want to inherit. So when you look at the little graphic down in the bottom right-hand corner, yes, it's people, but let's imagine those are programs. By granting the user permission to call that very first program and telling the system that that program should include the permissions of app owner, it's going to have a cascading effect, a domino effect into the rest of the application, okay? Because all of the gray programs have been set to benefit from the inherited values higher in the call stack. So all I have to do is indicate program 1 has the permissions of the owner included, and any subcalls within that will automatically benefit from it as well. So all I do here is indicate program 1 uses adoption, that's the user profile star owner, and then I give permission to the appropriate application users to be able to invoke program 1. And that's it. Everything else is automatically handled by the fact that this adopted authority automatically cascades to any subcalls that you see. If we look at it from a slightly different angle, here we see the entry program giving the authorized user permission to call that program. Perhaps that program lives in a library that the user has limited access to. But when the program runs and inherits from the entry program the adoption of app owner, that's going to get us into the library that everything is stored in from a file perspective. In this case, all these files are also owned by app owner, so these programs can get at them. The benefit here is if the user tries to come at the system or come at the library from a different direction, maybe coming in here with query or something, they won't be able to get in because it's all public exclude. Only if they come through the entry program will they be able to elevate their privileges for the length of the program invocation to gain access to the objects. It's like magic. There are some considerations within this model. Number one, what if there are objects being created during the runtime of the app? So if there is a check posting process whereby user 1 creates the file and then user 2 runs with the file, we have to consider that. Again, when we create those objects, remember, we have to not only create the object itself, but we also have to acknowledge that there's probably a change of ownership required and the assignment of a public or private permission for the other users. We also have to consider if there's non-5250 access, meaning that if we're coming in through FTP or ODBC, obviously they wouldn't be allowed in. And if that's a desirable scenario, we have to elevate the privileges there somehow. Again, swap profiles can be used for that. You've just got to consider it. Query access, same thing I just described, as well as with the IFS. We again have to use swap profiles because adoption would not help us there. So there are some nuances here, but in its very basic form, hopefully you can see that it's not overly complicated. All right, let's talk about some integrity considerations I want you to be aware of. Number one is that when we promote programs from a test or QA environment into production, it's very important that we have the right attributes assigned. And a change control tool is very beneficial in this regard because you can set rules and it's not something you have to rely on somebody remembering. So having the correct ownership, the user profile attributes, the public or private permissions can automatically be handled consistently as the program is promoted. So I'm a big fan of those types of tools. We also have to consider if we're going to restore this application. And when you restore an app, what you have to first do is restore any profiles that are owner applications, or excuse me, owner profiles. Then you have to restore the application, and then you have to restore the permission to the application using what's called the restore authority command, which is interesting, not actually pulling anything from media, it's actually just reapplying the private permissions, if you will. This is part of the reason why this approach works very well, because in a traditional application environment where we're not paying attention to the owner profile, we either have to restore all user profiles, because it could be any one of the programmers that has ever existed, or we have to just not pay attention, and all of a sudden things are owned by Q default owner, et cetera, et cetera. So having it owned by one, maybe two or three individual profiles across the entire application makes this restore function a whole lot simpler than otherwise it would be. Okay. I've got a note down at the bottom. One of the things, especially if you don't have change control, I like to include a builder program, which is a reference I use to maybe a CL program that can spin through all the existing objects and assign the correct permissions to them. Now, this is something that makes sense to build as you go, meaning as you create a file or create a program, add a line item to this builder program or several line items to make sure ownership, public and private permissions are the same. You can also use PowerTech's Policy Minder product, which can really apply permissions based on a baseline. So that's a much simpler way to do it through our commercial tools as well. I also want to mention a concept called HSP, which is hardware storage protection. This is a concept that most people are not familiar with. Bottom line is you don't need to know the intricacies of it because it all happens down under the covers. But in essence, what it means is that the operating system has its own protection. And it's important to understand that in some instances, this protection is only going to be active if you are at level 40 of security or higher, which is measured by a system value called Q security. So if you don't know what system level your server is running, do a display sysval on Q security, and if it is not 40 or 50, then we should probably have a conversation. Now, in addition to HSP, we also have domain validation, which means that the system is going to ensure that anything accessing memory pointers is done only through legitimate applications. Here we see an example of an object called signoff in library QSys. This is actually an object domain of star system, which is going to suggest that it lives as part of the protected part of the OS. When we look at CL programs, here's our trusty config program that we used earlier. You'll see that the program state here is star user as opposed to star system. That's important because what we recognize is that system state programs can access objects that are in either the user or the system state. In other words, the OS can do whatever it wants. However, programs that were created outside of the OS, which are running in user state, are only permitted to access user domain objects. So we have a protection mechanism inherently in IBM that is unique to our operating system. User domain objects for user space, user index, and user queues can be created in QTemp, plus anywhere listed in another system value called QAllow object domain, which by default I believe is star all, meaning they can be created anywhere, but certainly something that you may want to consider changing once you get a little more advanced with security. Okay. Again, this domain and state compatibility is enforced only at security level 40 or 50, and so again, good reason that you want to be there to protect damage to your operating system. I also want to talk about Trojan Horses. Now, as a programmer, I was taught that we should always use the library list. We never want to hard code libraries inside an application. Now, that was partly because I worked for a commercial application vendor, and we never knew whether application was going to be deployed into a different library name or how it would be migrated. So I certainly learned very early on in my career that hard coding a library is undesirable. But what we find is it's actually a security exposure potentially, because if we're using the library list and I manipulate the list or put a program of a conflicting name higher in the list, you're going to call my program, not the official one. Okay, a good example would be somebody putting a library above the QSys operating system library, taking the power down sys command and calling it work spool file. Now, that doesn't necessarily work quite as easily as it sounds, but if you think about it, then the next time somebody runs work spool file, they're going to have a bit of a surprise on their hands. So we've got to find a middle ground. I'm not a fan of hard coding libraries, but what I like to do is what I call firm code a library, or soft code. What I'm doing there is embedding the name of a library in a file or a data area where it can be retrieved. So if I do have to deploy my application into a different place, or we have an agreement that this library perhaps should have had a different name all along, I don't have to rework my entire application and recompile it. I simply change the data area or file to reflect the new name, but it is preventing the possibility of somebody intercepting a program by manipulating the library list. So just look at that as a good option. We also know that menus are still extensively used. They're very beneficial, but they're not fully comprehensive. We don't consider them adequate security controls at this point. Part of the problem stems from the fact most of us who are using menus think of the fact that only users are accessing the data through those menus. And certainly maybe the only legitimate access is coming through those menus, but that doesn't mean that's the only possible means of access. We may also have ODBC or FTP, and that becomes problematic, especially if we have legacy applications that are not configured for object level security because we didn't think we needed it. All of a sudden, that data is leaving your system and you're the victim of a data breach. We can use a concept called exit programs, which are going to intercept those types of PC connections, augment the menu security that still works in the green screen, and apply a better control over the entire system. So if you've never heard of an exit program, or if you know that you don't have any, then that's definitely something that you should take advantage of. All right, just got a few minutes left. I want to introduce just some assistance here. You're attending this webinar presumably as you got some notification from Help Systems that we were hosting the event. Hopefully it's been beneficial. I've thrown a lot of concepts at you in a very short period of time. So if you're still a little gray on some of these areas, don't worry. This is definitely something that you'll learn over time, but hopefully, if nothing else, you've taken away conceptually that this stuff can be done, and it doesn't have to be as intimidating as perhaps you might have first thought. So Help Systems has invested very heavily into security. We have two arms, in essence, within this as a subtopic. One is through the PowerTech security products, and then also through some services that are offered, and that team is led by Kara Woodbury, who was the IBM security architect for many years. So we've got some really good resources available, not only on the software side, but also in the base operating system side. We're also authorized by NASBA to give out CPE credits for security education on those types of events. And we also are known as the publisher of the State of IBMI Security Study, which is a free resource that you can access from the website and take advantage of what we have learned over 16 years by researching security on live production machines. The software side of the business really comprises a number of different module solutions that are designed to address business pain points, ranging from exit programs to antivirus to policy manager, like I mentioned a little bit earlier, SIM agents, and even database management. So regardless of the pain point that you're likely encountering, we have most likely a solution here, not only on IBMI, but on other platforms as well. The solutions you see here are all for IBMI, but there are other tools within our security portfolio that extend beyond that. I mentioned during last session that we have a security scan feature that is extremely beneficial. This is what it looks like. You take your PC, it's a small Windows app that runs. It targets your IBMI server. It's non-invasive. It runs in about 60 seconds. It doesn't change anything, and it doesn't look at any application data. So you can do it in the middle of the day. And the end result is that you get a browser-based report that you can print or PDF and keep. It's entirely yours, and we even spend about an hour with you going through that. So what I'm going to do is, just in case there's some of you that are new to part 2 here because I know there were some registrants that were. I'm going to see if that's something that you're interested in. Let us know. If you'd like some more information on that, certainly we can provide that as well, because I know sometimes it's a little nerve-wracking to agree to something and you're not entirely sure what you're getting. So just indicate that you'd like some more info and we can certainly provide that to you. Just to give you some idea, we do about 400 or 500 of these for the IBMI community every single year. So this is definitely something that is tried and tested, and you're welcome to take advantage of that. All right, I'll just give you a moment to answer that, and then we will begin to wrap up. If you do have any questions from either the last session or this one, please feel free to pop those into the question panel. I'll be happy to answer those. If you prefer to send them through an email, you can do that as well, and I can try to put my email address here in the chat window, and we will, let's see, make sure I spell my own name right, which is why I'm putting it out here already. And there you have it. So just copy and paste that, and you're welcome to send me a question or a comment. Certainly love to get your feedback with regards to whether you thought this was a good session. It's a little bit different from the ones we've done in the past, but I thought this would be fun to do, and I know there's a lot of developers out there that can really add some great value to the security part of the conversation. And so if you are a developer, then hopefully you're going to take advantage of this information. And as you design your apps, you can put some good security into them already. All right. So head out to the website if you'd like more information. One thing that I tend to get questions, and I've seen a couple of them come up, and I'll just kind of address them here together. What about existing applications, right? It's all very well and good to have the luxury of building a brand new clean application. How do I take care of the applications that have lived on my system for 15 years? And the answer is, it's kind of a combination. Conceptually, everything that we've talked about here is still applicable. But the question becomes, how do I retrofit that model into the existing application? How do I know how much authority a user needs? Well, hopefully you are on version 7.3 of the operating system or later, in which case there is a feature called authority collection that allows you to, in essence, determine by the operating system how much authority a user has to an object and how much they need it. Now, I'm simplifying it there a little bit. It's a function that you can turn on a profile level at 7.3, and at 7.4 you can also turn it on for an individual object. So you get the ability to then, in essence, track all of the access made by that user or made to that object in 7.4, and the system will log it all for you. You have to understand what that log is providing you, how to read it. It's not necessarily in a permission order. It's simply there based on the user doing certain tasks, and it may even be summarized. So it's very important to know how to interpret that data, which is something our services team know how to do very well, can teach you how to do it. We have some webinars that we've done over the years on authority collection, so you can certainly go out to our website and access that. But that would be the way that you would help retrofit some of these concepts into your existing application. So it is absolutely possible, and certainly something we can help with. All right, let me see anything else. All right, so I don't see anything. So hopefully if you do have a question, feel free, like I said, to send it to me directly. Otherwise, thank you very much for joining me in this two-part webinar series. It was a great pleasure to present this content to you. Hopefully it's given you some food for thought. If there's anything else we can do for you on the IBMI side with regards to security or automation, then let us know, and we would be happy to do that with you. Otherwise, thank you very much. Enjoy the rest of your day, and we'll see you on an upcoming webinar. Take care, everyone. Bye-bye.